2021, and today we are going to explore and learn about the related rates. Let's go!
Related rates problems involve two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. Related rates problems expand the application of implicit differentiation, and they are often presented in the context of a story problem. Related rates problems can involve a wide variety of quantities, such as the radius and the area of a circle, the height and the volume of a cone, or the distance and speed of two moving objects. The chain rule is often used in related rates problems, whether or not time is the independent variable. It is important to pay attention to units when solving related rates problem, especially if the problem is presented in a story context. In a real situation, related rate help in so many important things in the community, such as agricultural, industrial, manufacturer, and water treatment sectors.
So, these are the objectives. First, to find the rate at which the radius change with respect to time when the height change at a particular rate by looking at the link between the changing radius and changing height of a conical tank. Second, to analyze the corresponding rates of change in a conical tank's height and the rate of liquid draining from the tank.
Oh guys, look at this flower. Isn't it beautiful?
Wow, what a beautiful flower it is.
Don't you want to have a garden like this too?
Yes, I have actually, but my garden needs to be watered out within an optimal measure. Therefore, I have made a project that involves in designing automated irrigation system for my garden.
Really?
Yes, but and I want to use a conical tank to store water and release it slowly. But I realized that I need to know the optimization for the filling and draining process so that the water are not overused and the plant will not die.
Wow, sounds like a great idea.
Yes, of course.
So basically, you have to calculate the rate of change of height of water per time for the process.
Absolutely.
But how?
How?
Danish conical tank can be illustrated as in the diagram. Danish conical tank with its vertex down has a radius of 20 meter at the top and is 48 meter high. If the water flows out of the tank at a rate of 40 meter cube per minute, how fast is the depth decreasing when the water is 32 meter deep? By using the related rate method, we can help Danish to find his solution. Since we are finding how fast is the depth decreasing when the water is 32 meter deep, we have to find the rate of change of height per time of the conical tank. We can assume the value of the height per time as the dH over dt. The rate of water flow out of the tank, which is 40 meter cube per minute, can be written as our dV over dt. Mind that the value of the dV over dt must be negative since the water is flowing out of the tank. We can calculate the value of dr over dt by inserting the value of radius and height of the water in the conical tank. Since we are only given by the radius and the height of the conical tank, we have to build a ratio of the conical tank first. The ratio of the radius and the height can be written as r over h, or is equal to 20 over 48. We choose to express the volume in terms of the h because dH over dV is needed. So R are put as the subject of the equation and R is equal to 5 over 12 H. Then we can insert the value of the R inside the volume of the cone and the value can be calculated. The final volume in the term of H are calculated and the value of the volume is 25 over 432 pi H cubed.
Now that we have found the volume of the conical tank, there are two ways to find the change of height with respect to time. The first method are by using implicit differentiation, which means we differentiate all of the equations with respect to time. Therefore, V will be dV over dt. Differentiate h cubed will get this. Then we insert the value of the depth, which is 32 meter height. After that, just simplify the equation until we find the value of dH over dt, that is negative 9 over 40 pi. Or, if you want to insert the value of pi, just write the last answer as negative 0.0716. Don't forget the unit of the height over time, which is meter per minute. Aside from that, chain rule method can also be used to find dH over dt. If we feel that the implicit differentiation method are kinda hard for us to use, we can use this method. We need something to fill these gaps so that we can cancel out and get dH over dt as the subject. We already know dV over dt and dV over dH. Hence, dV is chosen and both of these dV can cancel out each other to attain dH over dt. Now, just use this equation and insert the value that we have. 1 over dV over dH will lead to it changing into dH over dV. At last, when the depth of the water is 32 meter height, the value are inserted into the equation and simplified to get the final answer that represents the value of negative 0.0716 meter per minute, which are the same as the previous method. Ultimately, both of these methods can be used, so according to preference, we can choose which method to use that is easier for us.
In conclusion, related rates are essential for resolving manufacturing issues concerning conical tanks. Many process industries, including wastewater treatment industries, food industries, and chemical process plants, use impact result from conical tanks. Manufacturer can make wise judgment about production and quality control by knowing the rate at which particular variables such as the height or radius of the tank change over time. Related rates also give producers the ability to optimize the procedures for optimal effectiveness and little waste of errors. As a result, in the manufacturing sector, it is crucial to have a solid awareness of related rates, especially when working with conical tanks.
A special thanks to this reference that helped us making this video.
That's all from us. Thank you.